Hello students, in this video we shall see the examples on allied angles. In the last video lecture you have seen the definition of allied angles. Okay, if theta is any given angle, then the angles of the form n pi by 2 plus or minus theta are all called as allied angles. For example, you have seen, suppose I write n is equal to 1, at that time it becomes pi by 2 plus. If the angle is say pi by 4 like this, then the angle will be 2 2 is 2 plus 1, 3 pi by 4. Or in a radian measure, what you used to say, n into 90 degree plus or minus an acute angle. Suppose for example 60 degree, 30, 45, 90 like that. When n is equal to, you can take 1, 2, 3, 4 like that. Now, in this video we shall see the trigonometric ratios of allied angles, how to write the trigonometric ratios for them. Here I told in the definition, allied angle means it's a multiple of 90, means there are two cases. This n may be odd or sometimes n is even. When n is odd, at that time how we have to consider the ratios. When n is odd, the ratio changes to its co-ratio. What are co-ratios? Sine and cos are co-ratios. Suppose I have sine of 120 degree, I will write it as sine of 1 time of 90 degree plus 30 degree. Okay. 1 time 90 plus 30 is 120. 1 time of 90 means what is 1? 1 is odd. At that time sine changes to cos 30 degree. This is how we can change to their co-ratios. Sine changes to cos. At the same time, if I had cos of 120 degree, then cos could change to sine, reverse. Sine changes to cos changes to sine. Similarly, tan changes to cot changes to tan. Provided only when this one is, n is 1, 3, 5, 7 like that, odd multiple. Then third is cosec changes to sec or sec changes to cosec. But in case when n is even, then the ratio remains the same, will not change it. Then, and one more thing you have seen in the video lecture, the sign, sometimes it was positive and sometimes it is negative. So, the sign, as per the sign convention is concerned, we have to look at the quadrant in which the given angle lies. If the given angle lies in the first quadrant, all the ratios are positive because x-axis is positive, y-axis is positive. But in the second quadrant, only sine and its reciprocal is different from co-ratios. Okay, reciprocal cosec are positive because the angle will be like this. This is negative x-axis and this is positive y-axis. So for sine and cosec, if I take the ratio as y by r, y is positive, r is positive. So sine and cosec are positive. But for the remaining ratios, we are going to consider this x, adjacent side, and this adjacent side is negative. So in the second quadrant, all the remaining ratios except sine and cosec are negative. And when the angle lies in third quadrant, in the third quadrant, tan and cot are positive because if the angle is lying in the third quadrant, it will be like this. For this, it is a negative x-axis, this is negative x-axis and this is negative y-axis. So x and y are both negative, means when I take the ratio as opposite side divided by adjacent side, minus divided by minus, means it becomes plus. Similarly for cot, it is the reciprocal. And in the fourth quadrant, the angle may be like this. At that time, x-axis is positive, but y-axis is negative. So, cos and sec contains the ratio as x by r, adjacent side divided by hypotenuse. Since adjacent side is positive, in the fourth quadrant, cos is positive. Thus, we can remember it popularly by the rule ASTC rule. Okay, this ASTC can be remembered as all silver tea cups, all students take coffee, attend Shaila madam's trigonometric class, like that. Okay, I hope you have understood. Now, I will consider some examples. I will consider the examples. Write the trigonometric ratios for 120 degrees. So 120 degree, in the last doubt clarification you have seen, 120 degree can be either written as 90 degree plus 30 degree or 120 degree can be written as 180 degree minus 60 degree. I will solve the ratios of this for both. Okay, first let me consider sine of 120 degrees. Sine of Okay, you will write it as 90 plus 30. 1 time of 90 degree plus 30 degree. 1 time of 90 degree plus 30 degree. Now, okay, just now you have seen, if it's the odd multiple of 90, n is nothing but 1 here, 1 is odd. So, sign changes to cos. And then you will look at the quadrant in which this lies. It lies in the second quadrant. In the second quadrant, this sign is positive, so you will put positive sign as it is. Cos, for the remaining angle, acute angle, it is 30 degree. You know the ratio for cos 30 degree as root 3 by 2. Okay, this is how we find the ratio. Similarly, I can write this 120 as 180 minus 60 means I will find what is the value of sine of 120 by writing like this. Sine of 120 is equal to, I will first write it as 180 minus 60 degrees. Sine of 180 degree means I can write it as 2 times of 90 minus 60 degrees. Then 2 times of 90 means what? 2 is an even number. You know, whenever n is even, the trigonometric ratio will not change. It is kept as it is. So, there is sine means I will keep this side as it is on the acute angle 60 degrees. Again, you will look at the sign convention. It is the second quadrant. In the second quadrant, sign is positive. So, you have sine 60. What is sine 60? It is root 3 by 2. So, for both you have got the same answer. Okay, this is how we can find out the trigonometric ratios for some angles in the third, fourth quadrants. Okay. Similarly, I will find what is the trigonometric ratio for cos 120. Cos operating on 1 time of 90 degree plus 30 degree. Since n is 1, it is odd, cos changes to sine 30 degree. And in the second quadrant, you know, only sine and cosec are positive. There is cos here. This cos is negative. So, I will put negative sign. Minus, what is sine 30 degree? 1 by 2. Similarly, I can find out the ratio for cos of 120 degree by another way of expressing 120. What is another way of representing 120? 180 degree minus 60 degree. 180 degree means what? It's a even multiple of 90 degree minus 60 degree. So, whenever this is even multiple, this ratio remains the same. There is cos here means I will keep that cos as it is. Cos of the remaining angle. Remaining angle is 60 degrees. Okay, cos 60. And you know, sign convention, 120 degree means it lies in second quadrant. In the second quadrant, cos is negative because in second quadrant only sine and its reciprocal cosec are positive. Minus cos 60. What is the ratio for cos 60? Minus 1 by 2. Thus, we have got cos 120 is minus 1 by 2. Okay. Similarly, I can find out for tan of 120 degree. Tan operating on, you will write it as 1 time of 90 degree plus 30 degree. Tan changes to cot because it is one odd. So, cot 30 degree. And you know, sign convention, 120 degree is second quadrant. In the second quadrant, our tan is negative. So, minus. What is cot 30? You know, tan 30 is 1 by root 3. Cot 30 is cot 30 is root 3. Then, similarly, I can find out for tan of 120 degree in another way of expressing 120. What is another way of expressing 120? It can be expressed as 2 times of 90 minus remaining 180 minus 60 degree. Now, 2 is even means tan, it remains as it is, tan. And 120 means second quadrant. In the second quadrant, tan is negative. Minus tan of remaining angle, it is 60 degrees. Minus, you know, tan 60 degrees is root 3. Thus, the value of tan 120 degree is minus root 3. Similarly, cosec 120. Cosec 120 degree. It will be 2 by root 3. Sec 120 degree. Reciprocal of minus 1 by 2. It is minus 2. Cot of 120 degree. It will be minus 1 by root 3. I hope you have understood. In the next video, we shall see some more examples. Okay.